This is how you use your chi-square chart. So the things you need to find are the degrees of freedom, which is these numbers here, and your alpha, which are these numbers here. Usually the alpha is given in a problem. We'll go, let's say you're given 0.05 as your alpha, and your degrees of freedom is n minus 1. So you say you end up getting 10 for your degrees of freedom. So you take 10 and go on over to 0.05, and you end up getting 18.307 for your chi-squared number. And that's how you use a chi-squared chart. We're going to be determining whether the die is fair. Our HO, the die is fair, and our HA, the die is not fair. Alpha, we're using 0.05. And since there are 6 sides on a die, you subtract 1 and you get the degrees of freedom, which is 5. Now we'll move over. We rolled the die. We rolled 1 3 times, 2 8 times, 3 7 times, 4 12 times, 5 4 times, and 6 8 times. And we got the expected value. You take how many times you rolled the die, 42 times, and divide it by how many sides are on a die, and that's how you get 7. And then for the next part, you take the expected value, you subtract the observed value, and then you square it. And we got 16 for the first one, then 1, 0, 25, 9, and 1. And after that, you take the values you just got, and divide it by T? E.
Expected.
You divide it by E. And after you get those values, 2.29, 0.14, 0, 3.57, 1.29, and 0.14, chi-squared, you end up getting 7.43, the calculated chi-squared. And then after that, you take the degrees of freedom and alpha, and you get 11, chi-squared is 11.071. And then you take your chi-squared calculated and put it on the graph, and you fail to reject.
Ta-da!
I'm the Batman, and these are the grades of the students in my class. Students with A's, 25%. Students with B's, 15%. Students with C's, 30%. Students with D's, also 30%. Students with F's, 20%. HA, at least one is incorrect. I can't speak with this mask on. I'm gonna take it off.
Alright, so our observed values: 7 students with A's, 6 students with B's, 9 students with C's, 2 students with D's, and 7 students with F's. To find the expected value, you take the number of students in the class and multiply it by the percent of students that have that grade. So for A, you do 31 times 0.25, because 25% of the students have A's, you get 7.75. You keep following that pattern and you get 4.65, 9.3, 3.1, and 6.2. Then the next part, you take E, you subtract it from O, you square that value and then divide it by E. And you end up getting 0.07 for A's, 0.39 for B's, 0.0097 for C's, 0.39 for D's, and 0.103 for F's. You add all those values together to get chi-squared calculated, which is 0.96. Now, the degrees of freedom is 5 minus 1. 5 because there's 5 different letter grades you can achieve. Then you subtract 1 to get the degrees of freedom. Chi-squared table, you take the degrees of freedom, 4, and then take 0.05, which is alpha, and you get 9.49. And now, since x calculated is 0.96, it does not fall after 9.49, so therefore you fail to reject. This is a problem from 11.3. Our problem, our HO, we are deciding if gender is independent on which sports they watch, and HA is if the gender is dependent. We're using alpha is 0.05, and our degrees of freedom, we use 3 minus 1 times 2 minus 1, and why we do that is because there's 3 sports and then 2 genders. And then you subtract 1 from each and multiply it to get the degrees of freedom. Alright, so the sports we use are basketball, football, and baseball. Our observed values are what we collected, and for basketball for male is 80, football for male is 104, baseball for male is 76, for female, basketball is 61, football is 112, and baseball is 90. And to get the expected value, what you do, well, first you add up the rows. Like the basketball row is 80 plus 61 is 141, and you do that for all the rows. Then for the columns, you add up 80 plus 104 plus 76 is 260. To get the expected value, you take the row total and multiply it by the column total, and then divide it by the table total. And that's how you get expected for each one. So that's what we did there. And to get chi-squared, you take the observed value, subtract the expected value, square that number, and then divide it by the expected value, which is what we did there. And you have to do that for every section. So you do it for males basketball, females basketball, male football. You do all that, you add all the numbers together, and you end up getting 4.02 for chi-squared. And after that, you use the degrees of freedom and alpha, and use your chi-square chart, and you end up getting 5.991 off of that. And since for chi-squared we got 4.02, it does not fall after 5.991, so we fail to reject. This is a problem from 11.3. Our HO is that age is dependent of the type of movies they watch, and HA is age is dependent. Our degrees of freedom is 12, and how we get that is 4, which is the number of age groups we have, and 5 is the number of genres we have. We subtract 1 from each number and multiply them together to get the degrees of freedom, which is 12. We use 0.05 for our alpha. Now we'll go on over to the table. So the first number you see in each column is the observed value. So like the 5, 9, 4, and 5 in the comedy, that's our observed value. That's the number we got from going around and asking people. And then to get the expected value, you take the row total and the column total, multiply those two numbers together, and divide them by the table total. And after you go through all that math, get all that, then you plug the numbers you got into the equation right down there. Expected value minus observed value squared divided by expected value. And you do that for every single section. Add together all the numbers you get, and you get chi-squared, which is 4.15. After you get that, you take your degrees of freedom and your alpha, plug that into your chi-squared chart, and you end up getting 21.0126. And as you can see, 4.15 does not lie in the rejection region, so you fail to reject.